Determine the common ratio R of a geometric progression called a sub n, for which the first term is equal to 1 and the sum of the first 4 terms is 40. So let's apply our formula for finding the sum of a finite geometric sequence. The sum, 40, is equal to the first term times 1 minus the common ratio raised to the number of terms we're dealing with, in this case 4, over 1 minus r. Let's multiply the denominator on both sides, and we can move all the terms to one side of the equation. Now we have a 4th degree polynomial. In order to find the roots of this polynomial, let's see if we can factor this further. R equals 1 is probably as a possible root to this equation, because if you say r equals 1, you do indeed get 0. So it means r minus 1 is a factor of this polynomial. So let's use synthetic division. The 4th degree term has a coefficient of 1. The 3rd degree term has a coefficient of 0. So does the 2nd degree term. The 1st degree term has a negative 40 as a coefficient, and the final constant is 39. And we're factoring out a r equals 1. As you can see, this divides perfectly evenly. So now the remaining polynomial we have is, in this case, we can see that r could be equal to 1. But this is actually not our answer, because the common ratio of a geometric progression cannot equal 1. And earlier, here, we had 1 minus r in the denominator. If r was equal to 1, this fraction would be undefined. So r cannot equal 1, which means the solution must lie in here. This polynomial must be equal to 0. There are actually many ways you can do this. You can either add in some terms and then construct something that is factorable, or you can use the rational root theorem, which basically says that the root will be in the form of some sort of p over q, where p is a factor of the constant and q is a factor of the leading coefficient. In this case, we will want to test out all factors of negative 39 over all factors of 1. So let's test out 3. Oh, we get 3 cubed plus 3 squared plus 3 minus 39. This indeed is equal to 0, which means r minus 3 is a factor. So we're left with r minus 3 times r squared plus 4 plus 13 is equal to 0. Let's see if this quadratic even has a real solution. We can use a discriminant to check that. B squared, 16, minus 4 times 1 times 13 must be greater or equal to 0. Well, we see that this is negative, which means there are no real solutions to this quadratic. So our answer, r, is just equal to 3, and that is our answer.